Section 8.7 is function notation. I can use function notation. When we use an equation to represent a function, it's often helpful to give the function a name, such as f or g. For instance, the function y equals x plus 2 can be written in function notation as follows. This right here, our symbol f of x replaces y, and it's read f of x. It represents the value of our function f at a specific x value. So f of 3 is the value of our function f when x is 3. And this is helpful anytime we're dealing with equations for specific problems, when we're dealing with cost or with heights or with various things where it's a specific type of problem, or anytime we're dealing with more than one equation. Rather than being like, that second one we used over there, we can specifically say f or g or p or whatever we want it to be. So in example 1, we're going to find a couple values using our original f of x. And these are f's. I don't know why they look funny on here, but these are f's. Okay, so f of x equals negative 3x plus 8. Remember that f of x is the same thing as y. It's just a different notation. It's a different label. So it doesn't mean multiplication there. It's just another way of labeling it. And we're going to find f of x when x is 5. And then we're going to find x when f of x equals negative 22. So here in A, we're going to start off with f of x equals negative 3x plus 8. We're going to find f of x. So I'm looking for f of x when x equals 5. So everywhere I see an x, I'm going to substitute in a 5. I see an x here, and I see an x here. So the rest of my equation stays just as it is. We just substitute the 5 in for our x's. Now, since I'm looking for f of x, and there's nothing else on the same side of my f of x, same side of the equal sign as my f of x, I can go ahead and simplify the other side. Negative 3 times 5 is negative 15, plus 8 gives me negative 7. So f of 5 equals negative 7. What this means is when x is 5, y equals negative 7, or f of x equals negative 7. So I can write that as an ordered pair if I want to. Something to keep in mind. I have an x value and a y value. So here I found f of x equals negative 7. In B, we're going to use the same f of x value. But here we're looking for x when f of x equals negative 22. So f of x equals negative 22. What that means is everywhere I see an f of x, I'm going to write a negative 22. So instead of writing an f of x, I'm going to write negative 22. And I keep the rest of my equation exactly the same. Now here I'm solving for x. That's the variable I'm looking for. And I do have things on the same side of my equation as my x here. So in order to get my x by itself, I first have to get rid of anything that doesn't have an x. So my 8. I get rid of an plus 8 by subtracting 8. That's how I get to 0. I get negative 30 equals negative 3x. Don't forget to bring that sign down with that value. Now, x is being multiplied by negative 3, and I get rid of multiplication by dividing. And I get 10 equals x. So here, x is 10, which is what we were looking for when f of x was negative 22. We could also say f of 10, since x is 10, equals negative 22, or we could write it as an ordered pair. X, 10, y, negative 22. So depending on what we're looking for, here we were looking for x, and we got 10. Feel free to pause here and give this a try if you'd like. Here, in number 1, we're looking for g of x when x equals negative 2. So x equals negative 2. So I'm going to keep my original equation the same. The only thing I'm going to change is every time I see an x, I'm going to substitute in that negative 2. So g of x equals 4 times x minus 5. And again, everywhere I see an x, I'm plugging in a 2. Now, I'm looking for g of x. So I'm looking for this value. Since there's nothing else on the same side as the variable I'm looking for, I can go ahead and just simplify my other side. 4 times 2 is 8 minus 5. And here I get 3. So g of x equals 3. We could also say g of 2 equals 3 because that's the x value that I used there. And as an ordered pair, remember our x is 2, and g of x is just like a y. So here, that is a 3. Go ahead and try 2 if you'd like. Here, our initial function, g of x equals 4x minus 5. I'm looking for g of negative 10. So the part that changed here, instead of an x, we have negative 10. What that tells me is that x equals negative 10. So everywhere that I see an x, I'm going to substitute in that negative 10. And the rest of my equation stays exactly as it is. The only thing, again, that I'm changing is that anywhere that I see an x, I'm going to put in a negative 10. Now, I'm looking for g of negative 10, which is what I have here. And since there's nothing else on the same side of my equation as my g of negative 10, I can go ahead and simplify the opposite side. 4 times negative 10 is negative 40 minus 5. And when I combine those, I get negative 45. So g of negative 10 is going to give me negative 45. In number 3, I'm looking for x when g of x equals 19. So the part that I'm looking for here is x. And g of x equals 19. So everywhere I see a g of x, I'm going to put in a 19. And the rest of my equation is going to stay exactly the same. Now, because I'm looking for x, and I have other things on the same side of my equals as my x, I have to solve this equation for x. First thing I get rid of is anything that's not being, that doesn't have an x in it, which is my 5. I get rid of a minus 5 by adding 5. Remember, we undo any addition and subtraction first. And now I have 4 times x. I get rid of multiplication by dividing. Those are my inverse operations. And here I get x equals 6. So when g of x is 19, x equals 6. To graph a function written in function notation, it might be helpful to first rewrite the function in terms of x and y. So remember that f of x is essentially the same thing as y. So we can write this as y equals 3/4 x plus 1 instead. Our intercept is at 1, and our slope is our m value. It's the number that's being multiplied by our x, our coefficient. We also could have done a table of values here. We could have found our x and y intercepts. Any of the ways that we've used to graph equations, we could have also used here. So my y-intercept is at 1. I put a point there. My slope is 3/4. That's my rise and my run. So I go up 3, right 4. Up 3, right 4. And then I can connect those dots with a straight edge. And an arrow to show that our line continues. And then I could label this as line F, or f of x. Feel free to pause here and give these a try if you'd like. We're going to graph the functions here. In 4, remember that f of x is just like a y. So I have y equals 2x minus 4. We can pick out our y-intercept, our constant at the end, and that's where we begin. We put our first point, and again on our y-axis. Our slope is our coefficient of our x term. Remember, it's mx plus b. And m is our slope. So here my slope is 2. And we can write integers as over 1. So 2 over 1. I'm going to rise 2, run 1. Rise 2, 1, run. And we can continue that pattern up 2 over 1 all the way through our graph. We can then use a straight edge to draw in our line. And because I'm using multiple graphs or multiple equations on one line, I'm going to make sure to label this one as f of x. Second one here. Again, we can replace g of x with y. Now it's just in slope-intercept form. My intercept is at 3, my first point. My slope is negative 3 over 2. Remember, that's my rise over my run. So my rise is negative 3. I'm going to go down 3 from my initial point over 2. I go down 3 over 2. And again, down 3 over 2. From there, once we have our points, we can connect them with a straight edge. Got a little bit off there, but pretty close. Arrows to show it continues. And here, we can label this as g of x. Last one here, h. Remember, we replace h of x with y. So what I really have here is y equals negative 1. I only have one variable, so I know it's either going to be straight left and right or straight up and down. And since this is a y line, I want all the points that have a y value of negative 1. So at my intercept, and here, and here, and here, and any point that has a y value of negative 1. 6, negative 1. Negative 2, negative 1. 5, negative 1. All of those points. So I can connect those with a line here. Arrows to show it continues. And we will label that as h of x. So here I have different colors, and that helps to distinguish my lines as well. But if I didn't, by labeling them f, g, and h instead of y, y, and y, it helps us keep track of which ones we're talking about. Also, depending on what they could have been. One could have been cost, one could have been revenue, one could have been height, area. Depending on what it is, sometimes it's helpful to have that little bit more of a label. I'm going to stop this video here and we'll finish up with the last example on another one.